the camera cut off when I was about here. Okay, so we had established the integral you would get using cross sections perpendicular to the x-axis, where we had to integrate one expression from 0 to 4 because the region that we're looking for is bounded differently between x equals 0 and 4 than it is between x equals 4 and 6. Okay, so we found the bounds on both of these regions, and here is the integral. So we've already seen this. Now we want to integrate with respect to y, because for given y, we're bounded only by this line, and it's the same two lines in every case. So we have a much simpler integral, and all we have to do is figure out for given value of y what the corresponding value of x would be on this line and on this line. Well, that's a very simple process, and we were in the process, had actually completed this, but I think I was still blocking the camera. If y equals 2x minus 8 corresponds to this line, then we solve for x and we find the x that corresponds to a given y. Now we've essentially, this is what we do when we do the inverse function, although when we do an inverse function we switch the values of x and y, and we're not doing that here because we're trying to find the values of x that go with a given value of y. So solving this for x, we get this, so that's going to be our function of y that corresponds to this graph. That will be, in other words, our k of y function. Okay, well there it is, there's the k of y function. The h of y function, we just solve this function, the f of x function for y. The f of x function is 2/3 x, so you would have y equals 2/3 x. Solving that for x, we get x equals 3/2 y, so the h of y function would be 3/2 y. Then we integrate the function with the greatest value of y minus the function with the least.